Now that you know how to create and paint on a texture image, it's very important that you know what Blender does with this texture image. This scene file that I opened is actually the same file from the last lesson where I demonstrated painting 3D strokes onto our model over here in the 3D view. As you can see, our palette is still here. Our brush settings are all the same. Even our UV checker pattern is still there, but there are no paint strokes anymore. And that's because when you create an image inside Blender and paint on that image, that information is stored in RAM, or your computer's memory. And then when you close Blender, your computer flushes that memory. And when you reopen the same file, even though you saved it after creating the texture, that information will be gone. For example, let's just paint a big target on our model. I will hit Control S to save our file, and then reopen that same file, open recent, the latest one. And our target is gone. So if we want to save our texture information, we have to jump over to the UV image editor. At the bottom menu, we have image, and we need to save the image to the hard drive, save as image. And by saving it to our hard drive, Blender will no longer store this information in RAM, but instead as a separate texture file. And so now I can save the blend file, reopen it, and our target texture is still there. Now personally, I think this is a bit of a quirk of how Blender works, but I've seen a lot of beginners frustrated by this, so be sure that you understand what Blender does with your textures. Having said that, next I want to introduce you to an alternate format for painting in Blender that doesn't require textures or UVs, and it's entirely contained in our object data, specifically mesh data, just like our UVs are. We can activate this by changing our object interaction mode from texture paint to vertex paint. And like our UVs, these live in the object data panel. Below UV maps, here we have vertex colors. And so by activating vertex paint mode, we create a vertex color slot, where in this panel we can add several. However, only one can be active for rendering, and we can subtract them as well. But in terms of painting, let's change our color to a green and paint a stroke on our 3D model. Since these don't require UVs or image textures, we can get rid of our UV image editor. And now let's start to paint a stroke. And you'll see that this behaves quite differently than texture painting. Right now it's a very splotchy stroke. It's very blurry. There's not defined lines except for right here, which is an artifact from occlusion. And so with vertex painting, colors are assigned directly to vertices, as you probably guessed from the name. And so this is dependent entirely on the resolution of the mesh. If we enable our wireframe down here with this button, you can see that if I paint directly in the center of a face, as I click, nothing's happening. But as I click and drag towards a vertex, you'll see it light up our green color. And so if we want a higher resolution painting experience with this, we need to increase our geometry count. Over here in our modifiers, I have a subdivision surface modifier enabled, but vertex painting doesn't care about the modifiers. It only operates on the underlying mesh. And so if I apply the subdivision surface modifier, you can see that our geometry is much more dense. And as I paint, we're getting more of that traditional stroke-like behavior. And the higher that I go in terms of geometry resolution, adding another subdivision surface, 2 subdivision levels, and applying it, with this amount of geometry, our stroke becomes much more higher resolution. Let's switch colors to make it a little more visible. But of course, this is at the cost of memory and computing power because we're dealing with a much more dense mesh. If you've ever used ZBrush, this is very similar to the poly painting method that program features. But as far as Blender's painting system, this is slightly different. If we click on our brushes, these are different from texture paint mode. And even though vertex paint tries to occlude, as we can see as I paint this ear, there is harsh artifacting that occurs from that occlusion, and there really aren't settings to control that. But it can be very useful. One of the most common features that I see used with vertex painting is something called dirty vertex colors. Now I'm going to jump to object mode and actually remove this Suzanne head. Let's add another one because I want to show you this tool with our geometry at our original low resolution. I will smooth our shading, add a subdivision surface modifier to level 2, and then hit V, which is the hotkey for vertex paint mode. And down here in our paint menu, At the top, you'll find Dirty Vertex Colors. I will click that, and what this operation does is make our crevices darker and our edges lighter, which can be a very useful utility for supplementing a texture map or a material. And I've seen vertex painting also used in the game industry for baking lighting information to a model as well. Which, speaking of baking, that's what we're going to be looking at in the next lesson.